In programming, a controlled structure is any kind of a statement that can change the path that the code execution takes. For example, a control structure that decided to end the program if a number was less than 5 would look something like this. The path that the code takes will depend on the value of the integer condition. The code in the if block will only be executed if the condition is true. The import statement is used to load the Python system library. The latter provides the exit function, allowing you to exit the program, printing an error message. Notice that indentation, in this case 4 spaces per indent, is used to indicate which statement a block of code belongs to. Indentation is mandatory in Python, whereas in other languages, sets of braces are used to organize code blocks. For this reason, it is essential that you use a consistent indentation style. 4 spaces are typically used to present a single level of indentation in Python. You can use tabs, but tabs are not well defined, especially if you happen to open a file in more than one editor. If statements are probably the most commonly used control structures. Other control structures include for statements, which allow you to iterate over items in collections, or to repeat a piece of code a certain number of times. While statements, a loop that continues while the condition is true. We are going to write a program that will ask the user to input an arbitrary number of integers, store them in a collection, and then demonstrate how the collection would be used with various control structures. Import system used for the sys.exit function. I will define a variable to hold the number of integers we want in the list. By now, the variable target integer contains a string representation of whatever the user type. We need to try and convert that to an integer. But be ready to deal with the errors if it is not. Otherwise, the program will crash. We want to define a list to store the integers. Count variable is used to keep track of how many integers we currently have. Keep asking for an integer until we have the required number. If the above succeeds, then is integer will be set to true. Only carry on if we have an integer. If not, we will loop again. Notice that I use double equals sign, which is different from the single equals. The single equals is an assignment operator, whereas the double equals is a comparison operator. Add the integer to the collection and increment the count by 1. By now, we have a list filled with integers. We can loop through these in a couple of ways. The first is with a for loop. The for loop is using a local copy of the current value, which means any changes inside the loop won't make any changes affecting the list. Or with the while loop. We already have the total above, but knowing the length function is very useful. On the other hand, the while loop is directly accessing elements in the list, so you could change the list there, should you want to do so. We will talk about variable scope in some more detail later on.